This is Learning Assessment Problem 9.5. The problem-solving strategy here will be that of average power in AC circuits. We are given this network and requested to determine the average power absorbed or supplied by each of the elements in the circuit. We have 3 passive elements and 2 voltage sources. Let's label some quantities to help us in our calculations. This top node, we'll call that V sub A. We'll consider the 24 volt source, give it a name VS1. The 12 volt source we'll call VS2. The voltage drop across this 2 ohm resistor we'll label as V2. And consider the current flowing into the 24 volt source, we'll call that I1. And likewise for the 12 volt source, we'll call this current I2. To begin the problem, we'll do a KCL summation of currents at the node V sub A. So we'll have VA divided by 4 ohms plus VA minus VS1 divided by 2 ohms plus VA minus VS2 divided by J2 ohms, and those 3 currents sum to 0. This equation can be rearranged in the form. So now we have the left-hand side of the equation in V sub A, and the right-hand side are the known voltage source quantities. This can be reformed in the polar format so we have a polar format form of admittance times V sub A is equal to a current phasor in the polar form. Or we can solve this for V sub A equals 14.89 at an angle of 7.12 degrees volts. Now we are ready to calculate the power dissipated in the 4 ohm resistor. The expression for that will be power is equal to 1/2 the magnitude of this V sub A voltage, which we've determined, squared, divided by the 4 ohm resistance. And this is equal to 1/2 times 14.89 volts squared divided by the 4 ohm resistance. And this obtains a result for the power being absorbed in the 4 ohm resistor equal to 27.7 watts. Now we'll solve for the voltage V2, which appears across that 2 ohm resistor. That equals V sub A minus VS1, which equals minus 9.225 plus J 1.846 volts. Or in polar form, V2 is equal to 9.408 at an angle of 168.68 degrees volts. Now the power in the 2 ohm resistor can be written as 1/2 times the square of the magnitude of the voltage V2 divided by the 2 ohm resistance, and this is equal to, or the power dissipated in the 2 ohm resistor equals 22.13 watts. For the other passive element in the circuit, the inductor, if it's an ideal inductor, the power dissipated in that element will be 0. So P sub L will equal 0 for average power dissipation. Now to determine the power absorbed or supplied by the VS1 source, we'll need the current I1, and I1 will equal the voltage V2 across the 2 ohm resistor divided by that 2 ohms, and that's equal to, which we'll calculate for the current I1 as 4.705 at an angle of 168.68 degrees amperes. Now we can calculate the power associated with the source VS1, which is the 24 volt source, and the expression for that will be 1/2 times the magnitude of the VS1 phasor times the magnitude of the current I1 phasor times the cosine of the difference between the angles of the voltage source and the current. This will be equal to, or the power dissipated or absorbed in the 24 volt source is equal to minus 55.4 watts. The negative sign here indicates that the 24 volt source is supplying power to the circuit. That was the result of the calculation of that phase angle for the current being 168 degrees, which is greater than 90 degrees, and that will produce, in the passive sign convention sense, a condition for supplying power. Now we need I2 current in order to calculate the power condition for the VS2 source. So I2 will equal VA minus VS2 divided by J2 ohms, which is equal to 2.775 plus J 1.846 volts divided by the impedance of the inductor J2 ohms. This in polar form is, or I2 is equal to 1.665 at an angle of minus 56.4 degrees amperes. Now we can proceed with the calculation of the power associated with VS2, which is the 12 volt source, and that will equal plus 1/2 times the 12 volts times 1.665 amperes times the cosine of the difference in phase angles between the voltage and currents phasors. And P12 volt will equal 5.53 watts. This is a positive absorbed value. You can sum the power in this network, and that will equal 27.7 watts plus 5.53 watts plus 22.13 watts. Those are all powers being absorbed by elements. And then we have minus 55.4 watts, which is the power supplied by the 24 volt source. This summation is approximately equal to 0, as we would expect.